right. Hello, students. So I had a lot of different video requests from you, and this one is just more examples of exponential growth and decay. And I think the most important thing to think about is what direction do we read graphs? We always read a graph from left to right. When you think about reading a sentence, you read from left to right. And so we do the same with graphs. And what that means is we start with small x values and we go towards bigger x values. So what I'm going to do is give an example of growth and an example of decay. So here is a quick example of growth. And so exponential growth just means that if I look at my x and y table, as my x values increase, my y values will increase as well. Let's go up to x equals 4. And so we can start with whatever number we want, pick a number, let's say 5, and then exponential means you repeatedly multiply it. So I'm going to multiply by a certain number. I want you to think about what number am I multiplying by? I'm multiplying by the same number every time, multiplying by the same number every time. I want you to notice that the x value is the number of times that I multiplied by that. And so my multiplier here is 2. And so what I have is a graph. If I wanted to draw a graph, it looks like this. It starts at 0, 5. We'll just kind of eyeball that. When I go one step to the right, it's twice as tall. When I go 2 steps to the right, it's twice as tall as that. You can see it's growing very quickly. I will not be able to capture much more of the graph because of the growth rate. That feature on the left is called the asymptote, where it is flattening out and never reaching 0. As you move to the right, we're multiplying by 2. I hope you saw that with the y values. Similarly, as you move to the left, reading it backwards, you are multiplying by 1/2 or dividing by 2. And the equation for this function is y equals 5 times 2 raised to the x. Because for every x value, I'm multiplying by 2. An example of growth in real world would be bacteria growth. If you have a couple bacteria, they split in twos, they double, double, double. Or when there's a baby being grown, it starts out as just a couple cells, and those cells split through a process called mitosis, and they double, 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 double. That's exactly what's happening with this example here. Another example would be if you have a bank account with some sort of compound interest. Compound interest grows over time. It probably won't double every year, but it will grow exponentially. Then an example of decay. Same sort of thing here. I'm going to make an XY table. I want you to look at it and see if you can discern what am I multiplying by. It might feel like division, but really you can think of it as multiplication. Let's start with y equals 50. Then we'll go down to 10. Or then we'll go down to 2. Can you see what we are multiplying by here? My next one is going to be 0.4. My next one is going to be 0.08. I am multiplying here by a fraction. And that's the big difference between growth and decay. Multiplying by a number that's smaller than 1 will decay. Again, it probably feels like division to many of you. And I hope you can see that what I'm doing is dividing by 5 every time. If I draw the graph of this, we have a high y-intercept, then it gets much closer to the x-axis as you go. And you can see every exponential function is going to have that asymptote. The question is if it's on the right side of the graph or on the left side of the graph. This is decay because it goes down and to the right. And this has a equation of y equals 50 times 1/5 raised to the x. As an extra bonus comment here, you might notice that the y values are fairly similar. They have the same sort of digits, just the decimal place is moved. And the reason why is because 1/5 is really the same as a decimal as 0.2. And so you can see I kind of used that to do the mental math, and I was just multiplying by 2 and moving the decimal. It's a nice trick. And so that's it for growth and decay.